Hey guys, so today we're going to learn about the mathematical systems in geometry, right? So now let's learn a quick background about this mathematical system, right? So it was actually, the concept was put together by a Greek mathematician whose name is Euclid, right? So he lived in Alexandria in Egypt about 300 years before Christ, yeah? So he wrote a book called The Elements, right? So he put together all things about, all theories about the whole numbers, algebra, and about the geometry concepts, systems, and a lot more he wrote in that book, yeah? So from that book actually has evolved where we are today, right? So people took that book and then they rewrote it with multiple editions, and by evolving is where we have reached in the mathematical system where we are today, yeah? Okay, so that's a quick background about who put together this concept. Now what is a geometry, right? Geometry is about studying about the globe. Globe, geo means globe, globe is earth, right? So earth and metrics means measurement, right? So it is to measure the earth, measure the globe, right? So that is what a simple understanding that we can have. So we will use this, the geometry concepts in our daily life as well, right? Whatever we look at, whatever we do, we can have, we can kind of have a critical thinking. We can think beyond box and then come up with some mathematical explanations to understand about things that is around us, right? So that is where this the concept is going to help us, right? So let's go little deeper into it, yeah? So for that, what I have done is, right, so since it is all about geometry, I have drawn a small picture that actually looks like your your town or your subdivision or the area that you're living in, right? Does it look? No, right? Yeah, it looks, guys. See, there is houses, swimming pool, playground, trees, and things like that, right? So I just want to explain you, I just want to make you to conceptualize, to visualize, to have a thought how this geometry works, because it is studies about the earth, measuring the earth. All the things that we are going to learn about, you can relate back to what is just around you in your life, in your daily life, right? So that is why I just want to explain using this picture, right? I'll just explain what is in the picture before I actually go into the geometrical terms, yeah? Right, so this is a place, right? There are roads. This is one road, and this is another road, this is another road, and this is another road as well, yeah? And there are houses along the road, along all the roads, house 1, house 2, house 3, and there is another house, there is a house here, and there is a house here as well, yeah? And what else do we have? We have a swimming pool just nearby, yeah, your house, and then just somebody is walking, maybe he's the he takes care of the swimming pool, and there is some kind of a plant here, and there is a tree, there is a kind of a ground to play football or anything that you want to play. And what else do we have? There is a library. Maybe let's take this building as a library, right? So this is what we have in this picture. This is couple of fields that we have nearby the subdivision. Maybe a garden or a vegetable field or a fruit field. You can take it as anything that you want, right? So this is what is around you in your daily life. You can draw even rivers, bridges, anything that you want, right? But this is what we see in our daily life, right? Got it so far? You understood the picture, right? Yeah, okay. So you might ask, what tree is this one? You can think of any trees, guys. I love mangoes. I will maybe use mango tree. Yeah, I will take it as a mango tree. Yeah, don't ask me where are the fruits. Yeah, okay, fine, guys. So now let's go into the geometry, the concept. Yeah, so what it starts with is something called undefined terms. Yeah, so from these undefined terms, then there will be defined terms, and there will be axioms and postulates and things like that, which we will see in the subsequent videos. Yeah, Okay, so we will start with something called undefined terms. Yeah, so what is undefined terms? A term that cannot be defined. Yeah, so the basic undefined terms that is used in geometry, yeah, that is what we are going to see. The first one is points. Points, yeah. So what is a point? Yeah, we cannot come up with a definition for a point. Yeah, a point is something kind of represented using a dot. Yeah, a dot. We can only describe how a point looks like, but we cannot come up with a definition. See, a point is a dot and the dot is a point, right? You cannot come up with any definition. Yeah, so that's why it's undefined term. And now how do we describe as per the geometrical view? So let me read it out for you. Yeah, a point has no size, no shape, no dimensions, no physical properties, and then it has a physical or a location, physical position or a location, right? And then it is represented by a dot and used a capital letter to address the point. Yeah, so now let's see what it is. Yeah, a point is first represented, as I said, it has no size, no shape, nothing, right? But it has a location, right? What is a location? You see here, there is a point here. This point represents this plant. Yeah, this plant. The point can be anywhere, just that you represent using a dot. Yeah, so this is a plant, maybe P1, right? Plant P1. And there is another point where a person is standing in this location, right? So this one P2, because we are using P, so let's use P here as well. So that's a person, so P2. And then what else you can see as a point, right? You can use, this house is somewhere as well, right? So this house is somewhere here. So this is a point. And this house is here. Maybe this is your house. So let's mark that with a point and then put Y, because it is your house, Y, yours, right? And then maybe this is your friend John's house. So let's use that John. So John's house is this one. And this one may be your friend Charles' house. So let's use C, point C, right? And then what else do we need to address? Okay, so this is another point, which may be it's house of your friend Bob. So this is point B, right? And there is another house here. So this one may be your friend Rose house. So point R. And then there is another house here, which may be Mary's house, right? Your friend Mary's house. So that is another point, right? This tree is standing somewhere in the ground. That is another point. And there is a library, right? Let's use the point as L, point L, because it is a library. You see? So you can mark any location, right, by a point to represent that particular location or the position. And it is represented using a dot. Got it? Yeah? Okay, so that is the point. Now, the next undefined term is line. Yeah, line or lines. The lines are represented using a straight line. Yeah, got it? Okay, now let me read the description. We cannot define a line. What is a line? A line is a line, right? Right? But we can describe how a line is made of, right? What is the line made of, right? Okay, so let me read it out for you. Infinite set of points arranged one after another, that's a line. It has no holes, no gaps between adjacent points. Extended infinitely on both directions, right? In geometry, it is assumed straight without curves and bends, yeah? And it has a dimension that is length, yeah? So this is the description of line. So now let's see what is each of them are talking about. First is the infinite set of points. Now let's see the points that is we are representing using dots, right? If you put dots one after another just next to each other without any gap in a straight line, in a straight form, what actually you will end up getting is a line. infinite number of dots. There is no count. You have to put lots of dots to form a line, right? Yeah, and the line has no end, right? It goes on both directions endlessly. You see, this is a road, right? We said it's a road. Do you know where the road ends? No, you just know what is just next to your house. As long as you see the road is keep going, right? So that is endlessly going, infinite length, right? And it is formed by infinite number of dots connected together next to each other in a straight form, right? In a straight form, that is how a line is, constructed, right? And the next one is, it says that in geometry it is assumed it is straight without curves and bends. You see, as long as it is straight in any direction, that is when we say it is a line. For example, if it has a bend, do we say it is a line? No. If it has a curve, do we say it is a line? No, right? As long as it is straight, that is when we say it is a line, right? Okay, so this is one line. Let's see. This is one line, this is another line, this is another line, there is another line as well, right? Yeah, okay. So now how do we represent a line? For dots we represent using capital letters, right? For line what do we use? We use any 2 points in a line using a 2 point, right? In this case, let's say J and Y. There are many other points, but we are just focusing on the points that we are marking. That's all, right? You take any 2 points, right? For in this case J, Y, and then put a line with an extended arrow on the top. That is one way of addressing a line. Or you can give an address which is using a small letter for all the lines. For example, this is road, right? You can say R1, this is road 1, this is road 2, and this is road 3, this is maybe road 4, right? Road 4. So this line, it goes straight across both the side. So this is a line R1, both direction. You don't need to use 1, you can use simply R also, but because we have so many roads, I'm using R1, R2, R3. Yeah, got it? But you use smaller letter to represent an entire line. Yeah, okay, got it? So that is how we write in geometry a line, right? So next is a plane. That is the undefined term called plane. Right, let me read the description. This has no definition to it. Plane means flat, right? It is flat, has no thickness, right? It has no thickness. It's just spread across all the sides, right? Let me read the description first, then I'll explain to you. A plane is infinite collection of points arranged in flat surface. The surface has no thickness, holes or pockets or ridges. It extends infinitely in all directions, and it has 2 dimensions. One is length and the other one is width, right? And it is usually represented by 4 sides of diagram, right? 4 sides diagram. And then to form a plane, it has to have minimum 3 points, right? So now let's see what each of them is talking about, right? First is, it is collection of points arranged in a flat surface, right? See, when you look at the grass, right? You might have seen grass. If you see each grass as a point, right? If the land is covered with full of grass, can you count the points, the grass? No, right? No. Or so the sand on the beach, can you count them? No. There are so many sands, but it is making the surface, right? It is making the surface. It is making it's a flat surface, right? A flat surface is what called plane. A plane is flat surface. So that also doesn't have any definition. But in geometry, how we represent a plane is using a four-sided diagram. It can be any dimension as well, right? It can have any kind of length or anything, right? But plane is not only having a four-side shape, it can have any kind of shape, right? Any kind of shape. Circle is a plane, triangle is a plane, a rectangle is a plane as well, square is a plane as well. But in the mathematical term, what do? We represent using a four-sided diagram. That's all. Yeah. Now I explained infinite number of infinite number of points put together in any order in all the directions is what we call it a plane, right? So I gave the example, the grass on the field or the sand on the beach, right? Got it? Yeah. So the whole thing is a subdivision, or your village or the town that I told, right? It's a collection of points, just that we did not mention it, right? Got it? Okay. So now to form a plane, you need to have more than 2 points. If it is only 2 points, it will only form a line, right? To form a plane, you need to have more than 2 points put together in different positions. For example, this is a swimming pool, this is a plane, right? Maybe there is a fish they put inside the swimming pool for collecting all the alkynes inside to clean it up, right? So there are 3 fishes, and all the 3 points we can make those 3 fishes or 3 points, maybe A, B, C, right? 3 points, right? Okay, but the whole thing is a plane. The whole swimming pool is a plane. Now you see here, this is a sports, right, ground, right, playground, right? So this is a plane as well, right? Okay, and then inside you have so many points, which is kind of the people, represented by the people, they are standing inside, right? Okay, and see, under the tree there is a shadow, that is a plane as well, right? Just because it doesn't have a square shape, it doesn't mean that it is not a plane. It is a plane still, right? And if there are more, let me use a different color, if there are more fruits have fallen from the tree, right, fruits have fallen from the tree, it's mango, then each fruit will actually represent a point under the shadow. The shadow is a plane as well. Now you see, each house is a plane as well. This library is also a plane, right? So anything that has a flat surface, that is without any thickness, yeah, it is called a plane. It is actually having dimensions as length and width only, right? Length and width. See, this is a length, this is width, this is length, this is width. How do we measure this one? They will also use a different form of length and width, that's all, right? But it's a flat surface, no thickness it has. It doesn't have any thickness. What else did we miss? It is usually represented using it is written using the points inside the plane. For example, we can give a short name, which is a small name, because this is a swimming pool. I'll use small s, lowercase s. So we can represent, for everything you can give, this one is a G, small g, and this one you can give a name. For this one, library, you can probably give a small letter, anything that you want to give. But let's use these 2 examples. So this is a plane S, or plane A, B and C, right? You can put all the points together to represent the plane, or you can use the single letter, the lowercase letter that you're using to represent a plane, right? Okay guys? Right guys, so sometimes what will happen is they will ask you to give some example for points and lines and planes as well, right? So for points, what you can give is like some of the examples that you can see on your daily life, the location of your house, or anything that is pointed, as simple as the point of a marker or a pen, or even your eye, what do you call, the apple of the eye, the black part of the eye, you can show that as a point as well. So anything that is pointed also can be used to give an example for points, right? For lines, what you can give is, right, other than the roads and all those things, you can also give, see, the edge of this board is a line as well. This side of the board is also a line. The table edge is also a line. The leg of the table is also another line, right? So you can give anything that looks straight, you can give, and it has the sharp edge, right? You can use that as an example for line. Now for plane, you can give an example of your house wall, your floor, or the table surface, right? Or the plate that you're eating, right? Yeah, so the plate that you're eating can also be a plane. Yeah, no, not joking guys, that's true. Yeah, and the food that is on top, you can use it for points. The chicken and the other things that you have on the plate, that can represent points. Yeah, okay, got it? Yeah, so everything mathematics, and when it comes to geometry, you can relate back to your life, the things that are around you. Yeah, got it? So this is all the undefined terms, right? So in the next video we will see the defined terms, which is evolved from these undefined terms, right? I will not erase this picture. I will continue to explain the defined terms, right, using this picture also. Let's meet in the next video. Yeah, thanks.